Welcome and thank you for joining today's webinar with co-founder and CTO of InGuardians, Jay Beale, in Attack and Defense Episode 4, Breaking into the Billu Box Virtual Machine. It's going to be a good one today, you guys. You are also joined by Beyond Trust Power Broker for Unix and Linux Product Manager, Paul Harper, who will run us through an overview and a demo of the solution after Jay's presentation, so please stick around for that portion. My name is Sarah, your webinar host today. A kind reminder to please submit your questions via the GoToMeeting console anytime throughout the webinar, and we will cover your questions at the end during our Q&A time. Also, today's session is being recorded. You will receive a follow-up email containing links to the recording and the slides shown here today within 1 to 2 business days from now. You'll also be able to find the PDF located in the handout section in the GoToWebinar console. So at this point, let's hand this on over to Jay, who will jump right in. Hey, Jay, welcome aboard.
Hey, Sarah, thank you very much. Okay, my name is Jay Beale, and I'm going to talk to you about do another in my attack and defense series. So I'm going to show you how we can break into an intentionally vulnerable virtual machine, and then how we can break that attack. So let's see. I've got a bio slide. Here's what I look like. I used to have hair. I think that bio slides look like a whole sea of text, and so I've decided that I'm going to have a different kind of bio slide too. So this is the kind of stuff I've been up to for, well, the last 20 years. Here's what we're going to do today. So first, we're going to do a demo where we're breaking into this Billu box intentionally vulnerable virtual machine, and then we're going to look at the attack path. We'll review that attack path and look for kind of weak points that we could attack back as defenders in that attack path, and then we'll break the attack. We'll talk about how we break it. We'll do a quick demo, and then we'll hear from Beyond Trust talking about PBUL. So let's go into our demo. I'm going to move off of the slides. We'll come back to the slides in a little bit, but real quickly, VulnHub is a site that I love because it has a ton of these intentionally vulnerable virtual machines, or you can also think of them as single-person capture the flag, or CTF machines. So this machine, these machines are put up as challenges, and the idea is you solve the challenge. You try to start from running the virtual machine and end up on root. End up with root. So the author is on Twitter, and his name is Manish Tanwar, and so we're going to go and break into his challenge now. It's called Billu Box, and I may be pronouncing the Billu a little strangely. But anyway, let's get into our demo. So I like to record my demos because the demo gods are all descended directly from Loki, and they are bastards. Sorry for the harsh language there. So my trick is that I basically for, I don't know, a year or two have been recording all of my demos, and then I talk through them and rewind if I need to. The cool thing is that means we can also fast forward. So here we go. So we're going to start out. We've run the Billu box virtual machine in VMware. You could use another system, but VMware Player is free. So we run VirtualBox in VMware, and then I have my attack system. And for me, my attack system is another virtual machine. It's Kali Linux. You can download Kali, and I strongly recommend, if you do download Kali, if you haven't done it before, download one of the pre-built Kali virtual machines rather than having the ISO and installing. So we'll start out. We'll find out what the Kali VM's IP address is, just to find out basically what subnet all the virtual machines are put on, and then we'll use a tool called netdiscover -R for range, and we'll say, hey, let's run netdiscover on our /24 on our Class C network, find out what hosts are there, and it runs really quick. It basically listens for ARP and it sends out ARP requests, and it says, okay, so there's our host is .30. So .1 and .2 and .254 are all being provided by VMware for its local network address translations. So .30 is the only host besides our Kali box on this network, and that's how we found the Billu box. So now I'll go and add that to my etc hosts file. So I'll call that IP address victim, so that for the rest of this demo, I don't have to keep typing that IP address and potentially confusing it with the one that I have for Kali. I can just type victim. And so now I'll run an nmap scan. I'll tell it not to ping just do a quick TCP SYN scan across every single port on the victim host. And this being a virtual network, it runs really fast. And so we found out really quickly we've got 2 ports. We scanned all 65K ports, none of this top 1,000 stuff for us. So we've got port 80 and port 22. We could attack port 22, that SSH server, but we know from reading, from reading what the guy said on VulnHub, what the author said on VulnHub, that he wants this to be a web-based one. So we'll go and put the victim URL in, and I've put :80. That's not necessary, but just to make it clear to everybody watching. And this brings us to the splash screen. And almost all of these intentionally vulnerable machines start with some kind of cartoon or movie themed splash screen. And so I actually don't know what movie or cartoon this is from, but this is a login page, and it taunts us and says, show us your SQL injection skills. And it gives us a username and a password prompt and a login button. I'm going to tell you that the next step that you normally take is to start trying your SQL injection attacks. And nowadays, back in the day, we had a whole pile of things we tried and we looked at the output. But now, at some point, somebody created a great tool called SQL Map that tries just a ton of all the things you would try and does it very, very quickly. And so I went and tried that here, and we didn't get anywhere. So SQL Map found nothing. So either the SQLi is a taunt, is a red herring to throw us off, or alternatively, it's just something that SQL Map can't find. So let's continue and see what we can do. So here's what I'm going to do. One of the things we love doing anytime you find a web server is you fire Dirbuster, and you give Dirbuster the URL for the web server, and you tell it how hard you want it to slam. So we're going to tell it, let's fire up 19 or 20 threads. You could, and all of those threads are going to fire as many requests as they can at the server. And what's going to be in those requests is basically a list of common files or directories, and those lists have different lengths. You can make your own. The longer it is, the better chance it has of finding something, but the longer it'll take to run. So we're going to go and grab one of the ones that came with Dirbuster. Everything in Kali Linux, every tool gets something, or almost every tool gets something in user share. So we go to /user share, we go find Dirbuster, and we're going to find our list of directories and files, what you'd kind of call a word list if this was a password attack. So we go into that Dirbuster word lists, and we choose basically one of the biggest ones there, the medium list, and we hit start. And this thing's going to scan really fast. It starts out at like 200 requests per second. It ends up at about 800 requests per second. So it's just hammering it with a ton of requests. In the time that I've been talking, it's gotten to 6,500 requests, and in the time since I said that, it's gotten to 10,000 now. And so you can see it's going really, really fast. The cool thing is it starts finding a bunch of PHP pages. If you look at this, index.php, in.php, c.php, show, add, test.php, head.php, and it finds them really fast. And what I've done now is I've paused it because while it can go through the whole word list and it thinks it'll take it about 52 seconds to do that, let's start with what we've got. Let's start with what we found. So the first thing I'm going to do is I'll look at the source code for index, for the main page, for that login page. And sometimes I'll find passwords or other hints in here. Sometimes you'll find old content, variables that have been removed from the form, but the application still answers to it. Okay, so we found that form. Let's go and try some of the other things that Dirbuster found. So here's an images directory. Okay, that is not the one we've seen. There's the one we've seen. That first one was what we're going to see when we break in. Let's try some of the others. Let's try some of the other pages that will show up. So we saw in.php. That's kind of cool. This is that PHP status page that tells us, among other things, this is an Ubuntu system, and it's running a pretty old kernel, 3.13. It's actually a 32-bit system. It's really, really nice when the sysadmins or DevOps engineers tell you what version the server's running of everything. We also found that it's running Sohosin, which is a nice defensive tool. So that was pretty cool to see. Let's try the other pages. We tried c.php and got nothing from that. It didn't do anything for us. It didn't render anything for us. Let's try the others. Let's try show. Show has the same result. It doesn't render anything for us. Let's try add. Add.php is actually a little more interesting. It says, hey, do you want to add, in essence, do you want to add a record? Do you want to upload an image file and enter 3 text boxes? I'm going to tell you that what I found, I'm not going to show you this, but what I found was that if you add an image here, it doesn't actually get added to the system, and that's basically because this page requires that you be authenticated through that front login page. But we know that functionality is there in add. So let's try another one. We had test.php. This one's kind of golden. This one's nice. This one basically says, hey, your file parameter is empty. You'll need to tell me what file you want. And that's really helpful because it suggests that this thing's going to read a file for us. Maybe it'll execute it. We'll find out what it does, but that's really useful. So let's actually try to interact with it. We'll take that URL. We'll fire up curl. And curl, think of curl as your command line based web browser almost. It lets you craft web requests on the command line. I learned how to use it out of a book written by Mike Shima that's on. It's like a web application security. It's a really old book now, but it's got a whole chapter or two on curl, and curl is just incredible. So curl is going to let us craft a request, and here we're saying I'd like to craft a post request. That's what happens when you fill out a post-based form, and I'd like to specify the data. In that data section, I'm going to fill in that file parameter, and let me just find out if Etsy password's readable. That's not going to give me passwords, it's just going to be a list of usernames, but the big thing it does is tell me if I can read arbitrary files in the system. And it turns out this test.php will let us read anything the web server can read. That won't include things like Etsy Shadow, because the web server is not going to be running as root, but it would include all the web content. So let's go look at what that front page with the SQL injection taunt actually does. So this is, a wonderful way of cheating, but as an attacker, everything we do is cheating. As a defender, we like to cheat too. It's just changed the way the game works. So if we look at this, here's our form. So this is the form. It says, we fill in a variable called UN for username and a variable called PS for password. And then those get stripped of any single quotes. Darn it, single quotes are really, really useful for SQL injection. And then they get pasted right into a SQL command, into a SQL select that's run. And the way this thing works is it does a select and says, show me any rows from the table, from the table auth, where the username is this and the password is this. Actually, where the password is this and the username is this, and that ordering is important. And it'll execute that. And if it gets back any rows where the username and password are a match, or rather where that SQL statement returns one or more rows, then you're authenticated. And so this is where we normally do our, single quote or 1 = 1 as one of these fields. Our problem is there's a single quote there. The single quotes are all stripped. So we kind of have a problem. Now, what I'm going to do, though, is it turns out, since we can see this, that we can, kind of ponder it and look at it. And I'm going to use an old technique. We're not going to use burp proxy or Peros proxy, one of the web proxies. Instead, we're going to create our own, copy of the form, as it were, or equivalent form on our desktop that will submit to the server, that will submit to that page on the server. And the reason I'm doing that is because, among other things, that lets us craft the post without involving another tool. It also makes it so that we can actually fill in what the value is if we want straight in here. The same way, that your submit button has a value that's fixed at let's log in. We can do the same thing if we want. So I'm just going to craft a little page here. And I've put in some new lines just to make the form a little bit easier to see. So you can see that we've got a name equals UN, we've got a text field called UN, we've got a text field called PS for password, we've got a submit button. And now I'm using a pre-tag, which means pre-formatted, and I'm just kind of adding some comments for us just to show you what we're trying to do. So we're trying to defeat this filter and this select statement. Well, there's one other thing I have to do with this form, and that is, since I pull it from the page, I have to tell the form what server to interact with. So I tell it, oh, hey, interact with victim index.php. We're going to use this technique again, and we will do some of that default value stuff on the next time. So now what I'm doing is I'm adding a little bit to this page, and what I'm adding here isn't useful for the hack. It's just there for me to be able to narrate and for us to be able to look at while we're thinking about this. So I'm trying to come up with a SQL injection, and the trick is I can't put any of my own single quote marks. I have to use the ones that are there. The cool thing is it's not filtering anything else out. So what if I put a slash in, and I can convert if I can put a slash in and I can convert one of the slashes that's already there into just a normal slash, not an escape for a single quote, that'll make a single quote, that'll make a single quote into an actual single quote in the SQL statement instead of into a part of the string. So what we're ending up doing is basically playing with the way that both PHP and MySQL parse out variables. But this is going to be a cool trick, and I'd urge you to download this and try some variations, because this isn't the only trick that works. All the tricks I found involve a backtick, involve a backslash. But we're basically going to make it so that our whole goal is to break out of the string and get it so that the stuff that we enter in to one of the strings can be an or 1 equals 1. And so I want to show you how this works. So I've created that form. I'm going to click it so it launches in my browser. Here we go. This is my version of the form. So my version of the form is going to go to the right place, but it's just this thing that I put on my desktop. So we're saying this is what we're trying to defeat. So let's try putting for password. We'll put in a single backslash, and for username we'll try our or 1 equals 1, and then the MySQL version of a comment, hyphen hyphen, which means whatever's on the rest of the line, go away. Whatever's on the rest of the line is a comment, and you should ignore it. And that returned one or more rows. It actually returned all the rows. Since the number of rows was greater than 0, we're in, and this is the welcome to Billu box screen. So we've gotten our first, this would be kind of our first flag, and we've gotten the first bit of functionality, and we can hit show users, and we get a list of kind of the application's users, and then we can go and say we'd like to add a user. And this takes us to that add form we were looking at earlier. Now this thing asks us to upload an image, and what we want to do is upload PHP, or we want to upload some kind of content that we can get to execute. And since this application's in PHP, getting PHP to upload would be great. I will tell you that I already tried, and we can't just create a PHP file and upload it with an image with a .gif or a .jpeg. It has to actually clear a basic test for whether it's the right kind of file. But we can do something about that then. So let's see what we do. So we're going to use Metasploit here, and we don't have to. You could use one of the reverse shells the way I have in some of these other Beyond Trust webinars. We could use some of the reverse shells that are in user share web shells. But I wanted to use Metasploit here. So we're going to use a tool called MSF Venom that basically makes a version of the Meterpreter, or a kind of reverse shell that's going to connect to Metasploit, and it makes it in PHP. And so for this, I tell MSF Venom, hey, go use the PHP version of the Meterpreter using the reverse TCP, so it'll connect back to me. And here's my IP address. So I've chosen .66 for my Kali box's, host number, and I've chosen 66 as my port, kind of an evil number I was hoping. And so I'm gonna create that PHP Meterpreter file, but I have to get it past a filter that says it has to look like an image. the cool thing is if you Google for magic number, you're going to find that there's certain set of bytes that has to basically go at the beginning of the file, and if they're there, they fool the file command in Unix and Linux, and they fool the other things that check a file's type. Without having to be valid in image files, we can make something look like a GIF just by putting GIF 89, the first 5 characters of a GIF file. You might call it a GIF file. I call it a GIF file. I think the CompuServe, when defining it, called it a GIF file. So we'll keep calling it that. So we put that at the beginning of our shell. We rename the shell to be shell.gif. Still basically a PHP file with 5 characters of who cares at the beginning. And if I can get that thing to execute on the server, I'm golden. So I'm going to move that onto my desktop just to make it easy, easier to find. And I will tell you that I've tried. I'll tell you that once we get this up there, I've tried executing straight, and that wasn't permitted, although sometimes it is. So I'm going to go and say I'd like to add a user. Here's his profile pic. His name's Hacker. His address is here. Give him a user ID, and he's been uploaded successfully. Now I went and tried just executing that GIF file by putting its URL in. I didn't get anywhere. So we're going to see what else we can do. If we want to, we will have to set up Metasploit to catch the shell. And so I'm using the multi-handler, which just accepts incoming connections. And I type show options because I always type that Metasploit. It's like the first thing I type after use. And there weren't really options to set just yet. So I'm going to set the payload and say, hey, this handler should expect PHP reverse interpreters, reverse TCP interpreters coming in. It should listen on port 66, and I try running exploit or run -j, and it says, hey, you didn't put lhost in here. I'm like, oh, right, okay. I need to set my Kali Linux machine's IP address, so I put in an lhost, and then I run that exploit -j. That means jobs, that it runs as a background job. And I get the image location, and if I tried pasting that in, what you saw real quickly is it doesn't execute. It says, hey, there's something wrong with this image file. We're not toast, though. That was the first part of an attack. Let's go and take a look. The thing that index.php took us to was panel.php. So let's go and read panel.php using that test, that test thing, the test PHP program that shows us the contents of any file. Let's look at panel.php. Now, you should know that anytime I'm showing you one of these attacks, there's a whole lot of things that didn't work. There's a whole lot of trying things and like, no, it wasn't that, no, it wasn't that. Anytime you see one of these, if the whole demo fits in an hour, you're seeing the abridged version. So I want to let you know, don't get discouraged if you get one of these vulnerable VMs and you're not having the same, you're not moving at the same kind of speed. Anybody who tries one of these, it takes them a while. If they're moving this fast, you're still missing. Even if they're moving this fast, you're still missing all of their, and that didn't work out, and that didn't work out. So I've tried to narrate a little bit of what of what I tried that didn't work, but there's a heck of a lot more in there. So here's our panel PHP page. It's got a form. There's this select box with 2 options, and there's a submit. So the 2 options are for the load variable, and then there's a submit box. It's called continue that sends in continue. And this part says, okay, if you've gotten the form, if the continue button's been hit, then take a look at the load box and put it into choice. If that choice is add, we're going to do one thing. If the choice is show, we're going to do something else. And if it's neither, we'll do something else. So if you look at the show option, we're going to include, which basically means we're going to execute this PHP code that's found in the current working directory in whatever's in that choice. So in this case, it's going to be show, show.php. And if it's add, we'll execute whatever's in add.php. But if it's not, we'll just run whatever was there. It doesn't have to have PHP on the end. Well, that sounds perfect, since what we want to do is run something that ends in .gif. So what we've got now is if we can submit this form with load set not to one of these options, but instead set to the file that we want to execute, and we put continue equals continue in there, then we get to run the code that we've just uploaded. Well, that's about perfect. So let's do that same kind of technique we did before. Let's make our own form. So we'll call this one Form 2. And this is a form sitting on our desktop. And we'll go to that select box. We'll set our action to the victim and panel. And now we'll go to that select box, and we're going to replace the select box with a text box. And that text box will have what we want it to have by default in it. So I go and I say input type is going to be text, and I say the name is load, so that we get the post variable load in. And I'm going to set the value. This is called a local file include, and they all basically start like this. I'm going to set the value to ... as many ... slashes as it takes to get out of that current working directory and to the root of the file system so that I know where I am, and then I'll put in the path that I really want. So let's look at the path on that image. That image is reached by the URL. Uploaded image is shell.gif. So what I'll need, since this was an Ubuntu system, the web content's usually in var dub, so let's try that. So I'll need to take that uploaded images and put in var dub before it. So this lets me basically say I'd like to run this program. And now I've got it. There's my desktop form. Let's go and open it in a browser. It helps that I'm already logged in with the same browser that I'm opening with. And I see that connecting box, and it's taken a while. And the reason it's taking a while is that PHP program is just going to keep running. And that PHP program is our interpreter. And so if we look now on our handler, we've just gotten this, we just got a connection in, and we're sending another stage of code over to the host.30 that just connected to us, and we're interacting with it. So let's run sessions -L to list our sessions. Okay, session number 2 is that interpreter. So I'll interact with it, and I'll type shell, and look, I'm dub data. I want to be root, but I'm dub data. Well, let's explore the system a little bit more. Let's look at our var dub. Oh, look, there are basically the things, those are the file names that we were finding with, those are the file names that we were finding earlier. And there's one other, which is PHP my, and I'm going to leave that alone as a hint right now. So I run uname, and I find that same version of the kernel that I found before. And now what I think about is, okay, I'm not root, but that's an old kernel version, and I remember that there's an overlay FS local kernel vulnerability. It's what we could use to escalate privilege to root. And so what I do is I go to my Kali system, and remember I said everything on Kali, every tool has something in user share. There's a whole lot of stuff in user share. There's user share web shells, which is a bunch of web shells we can use. There's also user share exploit DB with a full mirror of exploit DB. And so we can search, we run search exploit to search it, and we search for overlay FS, and we find, among others, this exploit right here. And it's against the kernel version we want. So this is the path we're going to copy out of, is this user share exploit DB exploits Linux local. And what I want to do is copy that path. I do a lot of copy and paste because honestly, if you want to do something well, you should do it the lazy way. And by lazy, I mean the enlightened lazy way. You want to make it so that you're avoiding errors by copy and pasting, or avoiding errors by automating, even better. Or avoiding errors by recording all of your screen share, all of your demos. So here we go. We try to upload that file, and it fails because I forgot to tell upload where I want it to go. So we're going to say, hey, upload into temp, and let's just rename this file to exploit.c. And now we'll tell interpreter, give us that shell again. And I'll run the compiler, and I'm going to compile the exploit. Oh wait, I need to tell it. That the output file is exploit and the input file is exploit.c. So -o for output, exploit, and compile exploit.c. And now I'll run temp exploit. And here we go. We've got root. So let's go back. This was our attack. So let's go and review our attack path. so here was our attack path. Let's find out what was weak that we could do something about, that we could leverage to break the attack path. And the idea is that whatever we do here is something we could have done proactively. It's not like we're going to know what the attacks are. But there are proactive steps. There are things that we call best practices that we've been doing, for years. There are, things that I coded years ago into Bastille Linux, and that I wrote in the first CIS Linux benchmark, and the folks over at CIS continued writing into benchmarks for a while. There are, this has progressed with lots of researchers finding even better things that are even more cutting edge. But there's just a whole lot that we can do proactively, and there's nothing like seeing an attack that it breaks to know why you want to do some proactive things. So that's what I like to show. So here's how our attack path worked. So first, we used NetDiscover to find the virtual machine's, the Billu box IP address. Then we ran nmap, find out what programs were listening on the network. We found a web server and an SSH server. We ran dirbuster to find PHP files, to find the active web content that was there. And then we started reading over that web content, and we found test.php was this nice vulnerable program that probably wasn't ever intended for any users to see. It was probably just there as some developer content, and it'll display file contents. Before you feel like that's just the kind of thing that you would see in a one person capture the flag machine. I've certainly seen that on pen tests and red teams. You'll find stuff that developers forgot about that they created as a quick utility so they could do something, and they left it behind. So this is real. So then we looked at that. We used that test.php, and we used it to read the front page code, the login form code, and that showed us how we could do a SQL injection attack. Even when SQL map was stymied. So then that got us access to panel.php, and we used panel.php to put a interpreter, a Metasploit interpreter that was written in PHP onto the server, disguised as a GIF file, and then we tried to run that GIF file, that PHP file, and it failed. So then we used test.php again to read a different page, to read the second page we got to. The one that the login form took us to, the admin panel, panel.php, and we found there was a local file include that would let us run our PHP code. And so that we ran that code via panel, and that got us an agent on the system, that got us an interpreter. And then we used a kernel level vulnerability to gain root privilege. So that was our attack path. Let's talk about how we could defeat it, and then I'll do a second little demo. So there are at least 4 good ways that we could defeat it, and I'm going to talk over each of these. This is a table of contents slide for our defenses, so don't worry about reading it over. The first thing is that if we remember, we used dirbuster to find all of these, to find that test PHP file, to find that thing that no user should have seen that lets you read any file on the system you want. But to get that file, we had to run dirbuster, and dirbuster was sitting there launching 800 requests a second, all from the same IP address at this system, and that's not normal behavior. So we could make that impractical. We could use IP tables to rate limit and make it so that you can't send 800 requests per second in. We could also, if we wanted to be a little bit more specific, if we wanted to have something that was more surgical than IP tables, and we wanted to get some detection, get emails that something was going on, we could use OSSec, an open source tool, and an OSSec can basically be watching the web logs and seeing the impact of that, and say, wait, that's too many from one IP address, and I'm blocking that IP address for a certain amount of time, and if that and when that certain amount of time is over, if that IP address still keeps going nuts, sending 800 requests a second, then then I'll block it for even longer, and I'll block it for even longer. And that kind of active defense can be really, really useful. I showed how to do that in depth in my June Beyond Trust webinar, and here's the link for it. Let's look at another technique. We could use mod security, which is basically an open source web application firewall, and that would have caught and broken the SQL injection attack on the login page. And that would have been really, really useful. And I did that in a different Beyond Trust webinar, and here's the link for that. One more reference to another webinar. Here we go. We could use AppArmor, and we could take those PHP, little mini web applications, and we could profile them with AppArmor and say, what should they be able to do? What do they normally do? And then we can lock them into that behavior, so that you could end up with panel.php loading a file that then started executing shell commands on the system. Because at the end of the day, that's what it did. We had this panel.php. It was meant to, let us show these tables from the database and add one to the database, but it wasn't intended to actually start running arbitrary commands on the system. And so AppArmor would be great for that. And I did a Beyond Trust webinar on that back in November. And then the last thing we could do is, and this is the one I'm going to demo for you, is most Metasploit, most people are using Metasploit they fire off an exploit, and then that exploit says, okay, I'm gonna get the server to connect back to you, so that you can do something. And making the exploits really, really useful generally involves a payload that you either have to connect to on another port, or that has to connect back to you. Almost nobody sets it up to start listening on another port for you to connect into, and they don't, because firewalls tend to get in the way of that. Everybody's really good at ingress firewalls. But the reason that the reverse shell works so often for us as attackers is that so few systems and so few networks have a good egress firewall, have a firewall that says, hey, we've figured out what's actually supposed to leave our network, and we're restricting things to it. So you can actually confine a machine pretty well with this. The big deal is basically normally your web servers, they're supposed to accept incoming connections, and all their traffic out is generally part of those incoming connections. If they do have to make any outbound connections, you know where it's to. It's usually to their patch servers. It might be to a logging server, but those IP addresses are well known. So your servers don't have to be able to create connections with arbitrary addresses then on the internet, much less with attackers at those addresses. So if you put on an egress firewall on the system, you could also do it on the data center or the cloud environment. You're going to break a reverse shell, and I want to show you how that works. So I'll go to my other video, and then we're going to wrap up, and we'll turn it over to Beyond Trust, and then you can come back to me with your questions. So we're going to run IP tables. The Linux firewall is IP tables. You can use other tools that modify your firewall, but they're all basically running IP tables commands. So here's a simple IP tables firewall for outbound. So normally the outbound firewall on a system is blank, and it has an output accept. So IP tables has tables of chains of rules. So we're taking the output chain, we're using F to flush it, to make it empty. We're setting a default policy on it to accept, which it probably was at already. And then we're going to say, okay, the first rule in this chain will be any packet that wants to go out is allowed out if it's being tracked with connection tracking, if it's part of an established session or related to an established session. So if it's the response packets to something that was inbound, or if it's a connection the system has to make out, like with FTP, where there are 2 channels. And then we'll add one more rule that says drop everything else. And this system will do everything it had to do before this, just like that. If you didn't know where you were going to patch to, you could drop that egress rule firewall only during patching, or you could get more particular. But let's see what that does to our exploit. So what we'll do is we've got that in place, and now we'll hit that second form that launches our exploit. Now we'll switch over to Kali, to Metasploit, and we'll see that we're not getting an exploit coming in. The firewall is blocking it, or so it appears. Let's confirm that. Let's go and take a look at the firewall, and let's remove that drop. Let's make it so it turns back into a default allow firewall. So we'll delete that, and now we'll go back to Metasploit and wait for the connection. We'll hit that continue button again to fire the exploit. Get a little impatient. I hit enter a couple times. I start to type jobs to get a list of jobs to make sure the exploit's still listening. And before I can even finish typing that, there we go. And I hit spacebar to get right past it. So I'll pause this again. So as soon as we eliminated that outbound firewall control, the exploit was able to connect back to us and got us control. So that should basically show you the value of an egress firewall. So again, there were at least 4 ways we could break this attack. I'm going to just jump back to this. There are at least 4 ways you can break the attack. We demoed one. We talked through the other 4. I bet there are even more, and I'd encourage you to do 2 things. So feel free to reach out to me on Twitter, and watch Beyond Trust and InGuardian's Twitter accounts for future webinars. But reach out to me on Twitter if you can either find another way to break the attack while keeping the application working, or reach out to me if you find other ways to break into this, because there were ones that I didn't mention, and that PHP directory that was found was one of them. Okay, well, at this point, I'd like to turn it over to Paul from Beyond Trust, and we can hear about PowerBroker, and then I'll take your questions.
All right, thanks, Jay.
Sure.
Okay, just clicked on share my screen. I got to make sure I'm sharing the right screen. Do you see my title page? Did that come up okay?
I do.
Okay, All right, fantastic. All right, so thank you very much, Jay. It's I present with you often, as you know, and it's always entertaining and very insightful, some of the stuff that you go over. It does make my head spin a little bit, and I'm sure there's probably other people on this webinar that feel the same. It's a lot of information in a short period of time. But what I'm going to do is, I guess as they say in Monty Python, now for something completely different, although it's maybe not completely different. So Jay's also gone over, really focusing on that the outside attacker, the external vulnerability and entering the system that way. But what I deal with, and what we actually spend a lot of time dealing with here at Beyond Trust, even though we do have a whole vulnerability management or detection and management side of the house, if you like, set of tools, I focus very much on the privileged account management, so more of the insider threat, right? So Jay spent a lot of time talking about all the various ways in which hackers or the bad guys, if you like, find ways to work their way onto a system. What I'm kind of dealing with are the people that you've already granted access to the system that need to be on a Unix box, maybe as root, or need to have those high privileges in order to do their job. So here at Beyond Trust, we have in our PowerBroker range of products a number of tools that help deal with the management of privilege for for your trusted people, the inside admins, the people that you're going to grant access to, but you want to grant access to in a safer way as possible. So again, I'm not going to talk about all of the various things that we do here at Beyond Trust, because we've only got like 10 minutes or so here at the end. But we will, we can actually help with managing, those privileged account passwords, endpoint privilege management. That's basically just a fancy way of saying rights on workstations like a Windows workstation or a Mac. And the world in which I tend to focus most of my time is in that server privilege management. And in particular for me, I focus almost exclusively on the Unix and Linux platform. So what does that really mean, right? So for me, we have a solution called PowerBroker for Unix and Linux that really eliminates the sharing of privileged credentials. It's really just a nice way of saying, for the most part, you don't need people logging on as root or using the root account. Really, it's any privileged account, but at the end of the day, this is Unix and Linux, right? So root's what we're talking about. And then auditing activity, right? So making sure that people aren't doing stuff that they shouldn't, or when they do, being able to perform those forensics to go and find out what they've been doing. The last bullet there talks about system level control. I'm going to kind of try and speed through these slides really quickly so that we can do a demo of really what I'm talking about, to give you kind of more of a feel for the capabilities rather than just going through slideware. Now, often when I start talking about PBUL, it sounds very much like sudo. We are absolutely a sudo replacement. There's a couple of points here. I don't really spend a lot of time talking to these. Just people do struggle a little bit with the management of sudo, particularly the ensuring that the log data or the audit data is good. Centralizing that audit data is also a big challenge. But we won't spend time talking about the shortcomings of sudo. I would definitely say if you're using sudo, it's better than not, for sure. It's certainly far better than logging on as root or sharing the root account. But the PowerBroker line of products and PowerBroker Unix and Linux go a lot further. Again, we've got a bit of a marketing slide here talking about some of those high-level business benefits. I've already mentioned, about auditing. We're very, very fine-grained control. With sudo, it's kind of more of the who, what, where, and when. We go to a much deeper level. Remote system and application control really means that we can control systems that you're not directly logged onto. So you can actually disable SSH so that you can SSH onto a box, yet still basically run applications or gain data from a remote system. Dynamic access policy, again, rather than having that very static sudoers type file where you just add like users and groups or groups of commands and you're forever editing that policy, we pull most of our data externally from things like Active Directory or LDAP or from database calls. File integrity monitoring, very important when you're dealing with privilege management, making sure that things on your system aren't being tampered with. That one actually floats across both sides, right? So when Jay's uploading additional files or tampering with files, those are obviously detected if you're doing file integrity monitoring. So from a security standpoint, that's something you should make sure that you have in place, regardless of whether you're trying to stop the the insider threat or the external threat. And then, having a whole bunch of reporting and analytics is really important just because of the scale of what most people have to manage. It's fine, again, when either myself or Jay's talking about, hey, here's somebody attacking a single system, but when you've got, hundreds or thousands or even tens of thousands of the systems that you have to manage, it's too much to basically rely on somebody going in and checking those hosts in a manual way. You need tools to do scanning and then do reporting and basically point you in the right direction. All right, so again, I'm going to go kind of really quickly through these next couple of slides. Centralized by design, it's really the big difference between us and sudo. Our policies are centralized, all the log data is centralized. We do indexing of the recording files. I've already mentioned the remote host control, that sort of stuff, and really, we provide a lot more power over what you get with sudo. One of those things is what we call advanced control and audit. Basically allows you to do, and these are just some high-level points, and this is probably what we're going to take a look at in a demo here in just 1 minute. The ability to do things like auditing what happens inside of a script, or give somebody a root level session, but still control what root can do to stop someone who is, again, an inside person that should have access to root, stop them from creating their own backdoors into the system. File integrity monitoring, again, I kind of just touched on this. I won't, again, go into too much detail, but things like, file name changes, file size changes, ownership, permissions, hashing a file, see if the hash changes. It's really basically saying, I've looked at this system, I'm happy with its current state. If something changes with a file or folder, then, alert me so I can go and investigate it. And then all of the reporting stuff, I kind of touched on this. Just making it much easier than digging through a whole bunch of textual logs. Again, when I demo, I tend to spend a fair bit of time at the command line. Jay just showed you a whole bunch of stuff, which again is very heavy in the command line view. It's hard for most people to follow some of that stuff and reporting and truly understanding it. Sometimes you just need that information digested and presented in an easier to use way, which is really where commercial products really start to come in and really show their power. So how does Power for Unix Linux work? This is the last slide, then we'll do a demo. It's hard to see from a command line perspective. I will try and point out where when we do the demo here in just a second. But effectively, it's kind of like a client-server type relationship. The client, we actually have two components. There's the submit host, or the client where you actually issue a command, as well as the machine where the command actually runs. But that's all actually authorized by a completely separate server. So the policy, or if it's easier for you to think of it this way, your sudoers file is actually stored in a separate location, as is all the audit data. So if you record somebody's session, that gets stored and indexed in a completely separate and hopefully secure part of your network. All right, so we got a few minutes. I'm talking a little bit about this. There's no way I can do like a full product demonstration, but we will just go and take a look at kind of what I was talking about and what that really means. So unlike Jay, I like to roll the dice with the demo gods, and we'll actually just do it everything live. So I'm actually going to hop over onto one of my Unix boxes, logged on as a regular user. I type who am I, It's just a user called demo1, right? So it's my first demo user. If I wanted to run that elevated in our world, you just type pbrun who am I. You can obviously symlink or wrap the sudo binary, and you'll actually see that it goes and gets processed effectively on a different server. So I'm logged on to server 2. It went to, in my case, server 1, keeping the names nice and simple to get approval. It was approved, so therefore it says it's going to run as user root, and then the output is root. We can do a lot more additional or intelligent checking around the command. So basically do some host, user, and command risk scoring, come up with a total risk score, and actually use that to determine if the command's going to be allowed. If I was to try and run a command like kill, for example, that's something that maybe I reject because, again, for my risk scoring, it goes up way too high. Again, you probably wouldn't want to allow who am I, and you probably really wouldn't want to block kill maybe in the real world, but it's just a very simple demonstration of the basic yes-no nature of command elevation, and obviously switching the user context in which a command runs. So when I do that, we can do, for example, if I was just to run the who command, when that runs, it's actually going to run as a user called AD user. So this is a user that actually lives in Active Directory, just showing you don't have to necessarily switch the user context to root. It can be any user, although root will be the primary one. So anyway, the main thing that I really wanted to show today, and again, there's a lot of good examples I could do, is as a regular user, you will have your admins often say, I need to log on as root. I need to do sudo su effectively. For this example, I'm going to start the session by typing pbrun bash. And when I do that, it will actually launch a shell. It changes the color because we have full control over the runtime environment. And if I was to type who am I or ID, you can see that I'm actually running as root, full root user, switch the user and the group context into root. So what I'm going to do first of all is I'm going to go to root's home folder, and in there I've created a symlink to reboot the system. So I'm going to kind of try and sneakily get in here and restart the system, and I get permission denied. So I'm like, oh, okay, maybe there's something wrong with my symlink. And again, just like Jay, I copy and paste as much as I can. I still get permission denied. So for most people, you're going to be like, hey, what's going on there? Now you'll see that reboot, or the reboot binary, is actually owned by root and group owned by root, and really everybody has execute permissions. So what we've actually done is grant root a privileged shell, but stop root from being able to restart the server. So I can actually block things like reboot and shutdown, so that, and again, this can be done so that you can really block somebody from doing a reboot just during like business hours, something like that. So let's just say this guy gets kind of crafty and he says, I'm going to do user add, we'll do safe user or something to try and trick people. Again, same thing, no way of running user add. I'm actually just getting denied. Again, permission denied. It's really the same thing, just with showing you like different binaries where actually can be blocked to safeguard this root session. So again, owned by root. Root does have execute permissions on user add, only I've actually blocked it in that root session. So last thing I say this guy tries to do is a password reset on root. He's like, okay, if I can't do anything with this session, I'll reset the password, and then I'll basically be able to log back on as native root and circumvent it that way. Again, we can block the password command. So there's lots of other examples I can use here, but I'm going to go and show you something else real quick, which is kind of cool. So I'm going to go over to my scripts folder, and in here there's a script that is owned by root, and only root can execute it. Again, one of those cases where somebody might have a valid reason to say, I need access to a root level session. If I was to come in here and, well, actually, I'll show you what's inside the script first, just to show you that there's a couple of crafty little things in here. Basically, this user's setting the script to basically redirecting it to dev null, so you can't see what's on the screen. He's trying to take a copy of the password file. We've got reboot in there again. Now the cool thing is when I run this script, and we'll just run it right now, you'll see the script starts and the script ends. Obviously, I showed you what was inside the script. You probably wouldn't do that if you knew your session was being monitored and you didn't want people to see what you were doing. I could have potentially uploaded this script, ran it, and then either deleted the script or replaced it with a different script, and nobody would have been any the wiser. So we've actually gone and done that run. What I'm going to do is I'm going to hop over to my central server where I'm logged on as a user called Amy. And if we look at what privileges Amy has, she can do a number of things. One of the things she can do is she can list all the logs that were created. We can replay them, that sort of stuff. So I'm just going to have Amy do a list logs real quick. And that will basically list all of the recording files, one of which I actually just started recording when we did that at the session. So now if type replay, I could type right. So if Amy does a replay on that file, she can actually come through and replay that entire session. I'm going to go kind of quickly. Everything that the user saw, typed all the way through, seeing out the script. I can move backwards and forwards. I can get timestamps. I can search for stuff. We have obviously a full web interface for looking at some of this stuff as well. This is just one way in which you can look at stuff from the command line. So Amy can do other things as well, like she can say, show me the history of that session, like what did the user do inside of that session. So you'll actually see the user come in, do the who am I, the ID command, directory listing, try and run my symlink, that was blocked. Tried to run reboot explicitly, that was blocked. Down here, all the way down to the last thing I did was actually ran my script. And also, that was where I was actually showing a script. But again, within this session, you don't see what the script actually did. So I can actually just update the history level to a history level 2. Just says, show me some more information. This time, when the script actually runs, you'll actually see what the system actually did. So not only can you see the contents of what happened inside that script, we can see in here that a couple of things, trying to add a user, trying to take a copy of the password file, they were blocked. We can also see that within this script, they were piping everything through dev null, so they were trying to hide what they need to do. So therefore you've got the evidence in your forensics. Again, all of this I'm showing you from the command line. We obviously have a web GUI that goes with all of this. There's no time to go through any of this right now, but you can see your systems, you can view all the hosts, and the main thing I really wanted to show you was all of that audit information is fully available here as well. So I can go and pick on, I'll just pick any random server. You can see all of those sessions as they're recorded and replay them here. And the last thing I will show you is the event log, the commands being where they're submitted, who they're submitted as, and then all of the information about those things. So I know I'm right out of time, so I'm actually going to go ahead and switch back to the slides. I think Sarah's going to wrap up with one final poll.
Yes, perfect. Thanks, Paul. That was you showed a lot in a small amount of time, so thanks for doing that. Let's go ahead and jump into our last poll, and then we had a couple questions come in for Jay. So you guys here at Beyond Trust, we'd love to help you with your privileged access management needs. Would you like to schedule a personalized one-on-one demo with a Beyond Trust security engineer? If you select yes, then somebody will be in contact with you to dive into a deeper conversation or even a more thorough one-on-one demo. I know Paul just touched the surface of PBUL, so if you're interested in seeing more or from any of our other products, select yes. Okay, so Jay, make sure you're off of mute, and let's jump into a couple of questions. This came in for you. So are there vulnerable virtual machines like this that don't require you to have web app hacking skills?
That's a great question. Yeah, there are actually. So this one and one of the other ones I've done on Beyond Trust have been web app focused, but there are certainly virtual machines that don't require any kind of web app hacking skills. Even some that might start with a web app, it just turns out to be a password security based thing, and if you can view source, that's enough. And some don't involve a web app at all. So you'll port scan and find your SSH or telnetting into something, and it's pretty darn fun. Thanks. Good question.
Another question for you, Jay. So why didn't you use SQL map to find a SQL injection vulnerability or SQL injection vulnerability?
Oh, sure. So SQL Map is normally my go-to, and it's an amazing tool, but it doesn't find everything, and so it's important if you are an attacker who's going after web applications or anything backed by a SQL database, it's important to still try things on your own when SQL Map fails. So I did try SQL Map. I just didn't include that here. It didn't bear any fruit, but so it went to manual techniques. Good question.
Jay, how would you break the attack if an attacker uploaded a PHP file that just ran shell commands without phoning home?
Oh, that's a good question, because the thing I demoed today was was using a firewall to break the phone home. So if someone were to upload a PHP, they could have uploaded a PHP script that just ran a pile of commands and the attacker didn't have to wait for the output. And one of my favorite ways, so I'd break before we got to there, but if they were able to get that bad PHP up there are two big things they could do. One I mentioned, and another one I didn't. So one thing we could do is we could use AppArmor and restrict that PHP program to do only what it needs to do on the file system and not go and run arbitrary commands. Another thing we can do is actually there are PHP configuration variables where you can say I don't want exec or system or any of the PHP functions that run commands on the system to be allowed to run, and PHP will actually stop that. And it's just built into PHP. It's not a security enhancement that came with Suhosin, although Suhosin can help if you're using that. And it's a neat little trick. Good question. If you ask me about it on Twitter, I'll tweet back and tell you about that one.
Alrighty. Well, we are 4 minutes past the top of the hour. Thanks everybody for sticking around, and thanks for submitting your questions as well. We really appreciate it. A reminder that you will receive an email with a link to the recording and the slides shown here today within 1 to 2 business days from now, and it will come from our email alias communications@beyondtrust.com. So be on the lookout for that follow-up email. You can also download the slides right now from the handout section in GoToWebinar. A big thanks again to Jay and Paul. Fantastic webinar today, you guys. Thanks for cramming all that information in 60 minutes. We really appreciate it. And thanks to everybody who attended live. Have a wonderful rest of your day, and we'll see you guys at our next webinar. Take care, everybody. Goodbye.
Goodbye.